Aluminum alloy refining is a crucial step in the smelting process that determines the quality of the melt. Its main purpose is to remove hydrogen, degassing, and non-metallic inclusions, impurity removal, from the melt. The quality of refining directly affects the density, mechanical properties, and surface quality of the subsequently cast products. Aluminum alloys are widely used in aerospace, transportation, and electronic communications due to their excellent physical and mechanical properties. However, aluminum alloys readily absorb hydrogen and attract non-metallic inclusions during smelting. These defects are often referred to as the cancer of aluminum alloys. Hydrogen can cause pinholes, porosity, and shrinkage cavities in castings, significantly reducing the material's airtightness and fatigue strength. Inclusions, such as alumina, silicon oxide, and carbides, disrupt the continuity of the metal matrix, becoming the initiation point for cracks and severely affecting the material's ductility, corrosion resistance, and machinability. Refining, as the core process in aluminum alloy smelting, aims to separate these harmful impurities from the melt using physical or chemical means. In actual production, the refining effect is often affected by fluctuations in key factors such as the type and quality of the refining agent, the degree of dryness, the refining temperature, and the settling time, leading to unstable melt quality. Here, we will elaborate on the requirements of Hydeb at aluminum liquid refining technology for gaseous refining agents. The quality and physical state of the refining agent itself are fundamental to the success or failure of refining. Inferior or damp refining agents not only fail to purify the melt but may also become new sources of contamination. Refining agent purity requirements. Chemical composition stability. High-quality refining agents should have strictly controlled chemical compositions to ensure that their decomposition temperature matches the melting temperature. If the impurity content in the refining agent is too high, e.g., containing large amounts of iron oxide or carbon powder, these impurities will directly enter the aluminum liquid, resulting in, the more refined, the dirtier. Particle size distribution. The purity of the gaseous refining agent should reach 99.996% or higher. Even trace amounts of oxygen or moisture will reduce the degassing effect. The dryness of refining agents, a core influencing factor, required. The dryness of refining agents is one of the most insidious yet fatal factors affecting refining efficiency. Mechanism of moisture harm. Hydrogen in molten aluminum primarily originates from water vapor in the furnace gas. According to Sievens' law, the solubility of hydrogen in molten aluminum is proportional to the square root of the partial pressure of water vapor. If the refining agent, whether gaseous or solid, contains moisture, the refining process becomes a gas-generating process rather than a gas-removing process. Therefore, the Hydeb at aluminum refining process requires the water content of the gaseous refining agent to be 2 ppm or less. Therefore, using a damp refining agent will cause the hydrogen content in the melt to increase rather than decrease. Impact on impurity removal. The alumina formed by the reaction of moisture with molten aluminum is an extremely difficult to remove hard and brittle inclusion that will severely contaminate the melt and form oxide inclusion defects. The Hydeb at process control requires that the gaseous refining agent undergo strict drying treatment, and the dew point should be controlled below -69 degrees Celsius.